So far we have seen that in 1 pulse diode rectifiers or single phase half wave rectifiers, only the positive half of input voltage is appearing at the output either directly or in a modified form. The negative half is actually not appearing at the output. So if we add some additional circuitry or some additional circuit elements appropriately, then we'll be able to utilize the negative half cycle of input voltage also, thereby achieving a full wave rectification. We know that in this circuit the diode conducts in positive half cycle of input voltage Vs. If we had another source which is identical to the source that we already had, it's also Vs, again both are Vm sin omega t, and if we connect another diode like this, D2, D1 is the original diode that we had and D2 is the new diode that we are connecting, and the cathodes of both diodes are connected together. Both sources are positive at the same time and they will also be negative at the same time. So these two diodes are in common cathode connection, and the diode with its anode at the most positive potential conducts. The anode of D1, that is this point, will be more positive than B in the positive half cycle of Vs. Why? Because this voltage is positive and the other voltage will also be positive in the positive half cycle because two are identical sources. So A will be more positive than B, and in the positive half cycle A conducts. And how does the current flow? The current flows like this. Now what happens in the negative half cycle? In the negative half cycle, B will be more positive than A because again both are identical sources. So D2 will conduct, the second diode will conduct in the negative half cycle, and the current flows like this. And how does the output voltage look like? Let us say this is the output voltage that we are looking at. In the positive half cycle, when D1 is on, VO is equal to Vs. And in the negative half cycle, VO is equal to minus Vs. Why? When D2 is conducting, the point B will be connected to K. So negative terminal of Vs is connected to VO, the positive load voltage terminal that we have defined. So VO will be minus Vs. So if you look at the waveforms, Vs is a sinusoidal waveform as shown here, which is positive and negative, and VO will be equal to Vs in the positive half cycle of Vs. So it is positive from 0 to pi, and in the negative half, that is from pi to 2 pi, VO will be equal to minus Vs. That means the negative portion of the input voltage gets flipped and becomes positive and appears across the output. So that is how we are ensuring that even the negative half cycle is utilized. But what is the challenge here? The challenge here is to have two identical sources. How can you create those two sources? Two identical sources can be realized using a transformer. Let us say we have a transformer with N1 turns on the input and 2N2 turns on the output, and we take a tap from the midpoint of the secondary winding. Then what we'll have? We'll have N2 turns as one part and another N2 turns as the second part, and the voltage across these two windings will be identical. That is how we can realize two identical sources for a single phase full wave rectifier with two diodes. The need of transformer can be eliminated if we utilize the common anode connection of diodes as well. So here we have 4 diodes and 2 of them are connected in common cathode connection and 2 of them are connected in common anode connection. So D1 and D4 are connected in common cathode connection and D2 D3 are connected in common anode connection. From our previous discussion, we know that the current coming out of the common cathode terminal has to be positive and the current entering the common anode connection also has to be positive. When A is at more positive potential than B, D1 conducts and current flows like this. We also have to understand that when A is more positive than B, B is more negative than A. So D2 also conducts when A is more positive than B. And when D2 conducts, current direction will be like this. In the negative half cycle, A will be more negative than B. So from the common anode pair, D3 will conduct, and since B is more positive, D4 will also conduct. So if we connect a load between K and N, the points K and N, it will look like this, and we can connect a source between A and B, that is our Vs. Now in the positive half cycle, D1 and D2 conduct, so the current flows through the diode and the path gets completed like this. Current flows back to the source. In the negative half cycle, D3 and D4 conduct, so the current flows through the load and flows back to the source like this. And how does the output voltage look like? If we define the output voltage VO like this, it is equal to Vs in the positive half cycle. Why? Because D1, D2 both are on. So A is connected to K and B is connected to N in the positive half. So VO is equal to Vs. And in the negative half cycle of Vs, D3, D4 will be conducting and K will be connected to B now and N will be connected to A now. So VO will be is equal to minus Vs, and we will have again the same output voltage waveform when the load is a pure resistor as shown here. So in the positive half cycle, D1, D2 will conduct. In the negative half cycle, D3, D4 will conduct. This is how we can achieve full wave rectification without the need of two identical sources created by a transformer. So there are two kinds of 2-pulse diode rectifier circuits. One is with two diodes and a center tapped transformer, and the other is with 4 diodes which does not need a transformer. And of course the load can be a resistive load in the simplest case, or we can add an inductor to smoothen the current waveform as we have done in the case of a half wave rectifier, or we can have a capacitor at the output, that is C filter and R load. This capacitor will smoothen the voltage appearing across the load, and we can also connect an RLE type of load which represents a DC motor at the output of this rectifier. This 4 diode rectifier is also known as a bridge rectifier. We will try to understand these circuits one by one by comparing against their half wave counterparts.